Okay, so today we're going to go into lab 6. In this lab, we're going to learn the basic input-output of 8051. In previous lab, we already learned about the output of 8051. So today we're going to learn about the input also. So there's input-output in our program in this lab 6. As we discussed before, the input-output can be defined by writing logic 0 to the port, then you will configure the pin to output. If you write 1, you will configure the pin to the input port. And in 8051, there is a 4 I/O ports, and each one is an 8-bit. So total you have a 32 pins at the 8051. And this is just some specification of the current limit, how much power it can sending out from the microcontroller to light on the LED. And this table telling you that apart from the input-output functions, all the port pins they have alternative functions, right? Remember, when you look into the pin layout, there's some certain other functions on certain pin. Except port 1, the other port also have other functions available. So in this lab, you're going to starting to use the input and output of the 8051. So as we learned before, if you put 00 means you set it to the output. If you put 1 means you set it to the input. So FF means you put all 8-bit equals to 1, right? In hexa FF. Okay, so you set your port 1 to output because you put 0, and you set your port 2 to input because you put 1 here. Then you move P2 into A, then move A into P1. So basically your P1 will equals to P2, that's all. Then it will keep on looping. So you keep on running this coding. Okay, so this is the circuitry you're going to build. You have a switch and then 2 push button. So this switch is a 8-bit. You can sending 8-bits data, but you only use 4 of it only. Then the next one is using the 4 LED at this side. After you finish this one, then you will start to using the second coding. So there's 2 coding in this lab. So basically this one is just getting the data from your P2 into your P1. Okay, so whatever if at your P2, so if you look at your P2, so P2 is here, which is connected from P2 0 up to P2 5, right? This is 0 1 2 3 4 5. Okay, up to P2 5 they are connected to the switches. Then 0 to 1, the 0 to 3 is the 8 pin switch. Then 4 to 5 is the push button. Okay, this is the push button. When you press the button, then it will on. It's just like a switch. Okay, when you on, you can on and off the switch. This is also the same. They are also operating as switch, but they combine in one row, 8-bit. Okay. So basically you equal your P1 equals to P2. So whatever data you send to your P2, they will go to your P1. So let's say now you are giving a logic 1 at your port 2 pin 0. Then your port 1 pin 0 will equals to 1 also. Okay, so let's say I give a logic 1 at this one, 0 at this one, 1 at this one, 0 at this one. So my port 1 pin 0 equals to 1, port 1 pin 1 equals to 0, pin 2 equals to 1, then pin 3 equals to 0. They will follow exactly what is the thing here because you are using this coding. You equal your port 1 equals to your port 2. So the register values inside your port 2 will be moved to the register value at your port 1. So that's why you can changing the switches here to give any values you want. Then they will on and off the LED according to the switch positions. Okay, so basically this connections is just pull up resistance. So you can see this is a 5 volt. Okay, so the connection is basically they are connected in this way, then a register, then they come to a switch, then they go to the ground. At here, they go to your microcontroller pin. Right, the switches here, all this thing is the same as this one, just this is the different types of switch. In here is a push button, in here is a DIP switch, but all of them are the same as this one. So if the switch is an open circuit, basically I'm supplying 5 volt to this pin. So if I on the switches, which means the pin is connected, then I'm going to connect this pin to ground, because the electric circuits will always select the easier path. In this side there's a resistance, so it's difficult for them to go through, so they will select this side, which is nothing, no resistance, it's just a short circuit connections, so they will go to ground if you on the switches. If you off the switches, then they will go back to the 5 volt. So it depends, you on and off the switches. Okay, this one is DIP switch, you can push up and push down to on and off. This one is a press the button on and off. So basically they're the same as the switches here. So this is the way you're giving the 1 or 0 to the input pin. If you connect to 5 volt, then you're giving a 1. If you press the button connected, you give a 0 volt, which is give logic 0 to the input pin. Then in the second coding, they are doing the same. Set your port 1 to output, port 2 to input. Then they will do this jump JMB. So the JMB means jump if a bit not set. Okay, so they will check the bit of port 2, bit number 4, to check whether bit number 4 is set or not set. If it is not set means it is at 0, set means it is at 1. Okay, they will check the port 2 register. This is 0, 1, 2, 3, 4. They will check this bit whether it's equals to 1 or 0. If it's a 1, then it will not jump. If not set, yeah. If it's a 0, then it will jump. So if it's not set means it's 0. If it will jump to where? Jump to this one, B1. So it according to what you pointed to. Okay. Then the second code is the same. They will check the port 2, bit number 5, whether they are jump or set or not. If they are not set, then you'll jump to B2. Okay. So if both switches, both bit also not set, then they will just skip the instruction and go to the next one. So let's say when I start to move P2 into A, I move P2 into A, so this is A equals to my P2. Then I will check my port 2 bit 4 whether it is set or not. If it's set, then I will skip, because if it's set, then I will not jump. Then I will go to the next one, check again. If bit 5 also set, then I will not jump. Then I will continue to here. I will move A P1, so this one is P1 equals to 0, 0. Then they will jump to start again. Then we'll keep on checking these 2 pin. Why they are checking these 2 pin? If you look into the circuitry, these 2 push button is connected to 4 and 5 of your P2. Right? So basically they are checking whether you press the button or not. If you press the button, they will go to 0, which is fulfilling this jump condition, not set. Right? If you didn't press the button, it will always equal to 1. So it will not do anything. It will keep just skipping this instruction, skipping the instruction, then giving you 0, 0 into your port 1. So port 1 is the one in here. So they are giving 0, 0 to your port 1. So if you press the button, then it will go to 0, then your P24 will go to will not set, equals to 0, which means not set. If it's 1 means set, right? So if not set, then they will jump to B1. B1 is here. So in B1 they put in another pattern, which is a P1 equals to 0A instead of 0, 0 in default mode. Okay, after that they will go back to start again. Then they'll check again whether you press P4, P5, P24 or P25 again. If you press P25, they will jump to B2 here. Then they give another pattern. Your P1, sorry, where is it? This one. Your P1 well equals to 05H. Okay. Your P1 well equals to 05H. So this coding is just to testing whether you press P1, P4 or P24 or P25, these two push button or not. Okay, whether you press these two push button or not. So this is the example coding of lab 6. Then in this lab you need to write a program that use a push button to stop the 4-bit binary up counter. Okay, you need to have a push button. When you press, they will start the 4-bit binary up counter, counting from 0 0 up to 1 1 1 1. Then you need to display the 4-bit binary up counter using the LED in the simulation, and take a video of the circuits to show the functions of the push button to start and stop the counter. So you press one time, they will start to counting up, and you press again, they will stop. And you press again, they will counting up again. Okay, so that's all for your lab 6.